Good morning guys and welcome to my channel Mind Your Math. Today we are going to do a few sums based on arithmetic progressions. So we will start with the nth term of an arithmetic progression. So first we will do a few sums based on this particular topic. So the first sum is here. If the mth term of an arithmetic progression is 1 by n and the nth term is 1 by m, show that the mth term is a 1. Okay, so as I have always told you, whenever you are getting a sum, write down the information that you get from the question, write down the information that you can apply to the question before you start sorting the sum out. Okay, so now in this particular question, what is the information that we are getting from the question? Here the mth term, so am, okay, is equal to 1 by n and an is equal to 1 by m. We need to show that mth term is a 1. Okay, this is what we need to prove. Fine. So am is equal to 1 by n. So we know the formula for the nth term. So suppose the arithmetic progression, the first term is a and the common difference is d. The nth term is given by a plus n minus 1 into d. Right? Now, this is information that we already know. This is something that we get from the question. So, what is the mth term? Formula. The mth term is a plus m minus 1 into d. That is given to be 1 by n. Similarly, an is a plus n minus 1 into d is given by 1 by m. We need to find the mth term. So, with this information, if you have to find that, we have to use some sort of manipulation. So now let us see what it is that we can use over here. So this is our first equation and this is our second equation. Let us see whether we can cross multiply because we have a fraction over here. So when I am cross multiplying this n to this particular side, what would I get? I will get a into n plus m minus 1 into d into n is equal to 1. Right? Now, a into m plus n minus 1 into d into m is equal to 1. Okay, so I have multiplied n here and I have multiplied m over here. It is basic cross multiplication and this is what I am getting. Now, I cannot do anything with this. So, I am going to open the bracket. So, an plus m dn minus n d is equal to 1. Correct? The second one becomes a into m plus n d m minus dm is equal to 1. Now, in these two equations, you can see that m dn and m dn, they are common terms in these equations and 1 on the right hand side are also common. So, when both the equations are equal to 1, I can equate both of them. I can say that this is equal to this because both are ultimately equal to 1. I have rewritten the entire steps starting from here. I have written the mth term, then I have cross multiplied and I have opened the bracket. Now I told you since the RHS of both the equations are equal to 1, let us equate it. So am plus ndm minus dm is equal to an plus mdn minus dn. Okay, you can see that m into d into n, m into d into n is common on both the sides. So I am cancelling it. Okay. The remaining terms is am minus dm is equal to an minus dn. Now, again, we need to sort out something so that we can group or some other manipulation. So, what I am going to do is, I am going to take m outside. So, I get a minus d is equal to n into a minus d. Now, you can suddenly see that a minus d is a common term on both the sides. Please do not cancel over here. Finally, you will get m is equal to n, which is not true. The reason being, mth term and nth term. So, the value of m and n are different. M cannot be equal to n. So, please do not cancel this. Take it out as a common factor and write this way. So, you know that m minus n cannot be 0 because the m value and the n value are related to the term number. So, we cannot do that. M is not equal to n. So, A has to be equal to D. Now, you got one result. Okay. Now, let us see how we can apply this. What do we need to find? We need to find the mnth term, which is amn. How do we find it? So, it is a plus mn minus 1 into d. Correct? the nth term is given by a plus n minus 1 into d, mnth term is given by a plus mn minus 1 into d. Fine. We suddenly found out that a is equal to the common difference d. I am going to apply it here. Instead of d, I am going to substitute a. You can substitute d in the place of a. It works both ways, okay. Now, here when we do that, this is what we are getting. So, a and a will get cancelled and the mnth term value we will get as mn into a. Okay, but that was not our intention. Our intention was to show that the mnth term, the value is a 1. So what we need to do, we need to show, if we show that m into n into a is equal to 1, our task is over. So now let us see how we can do it. We know that a is equal to d, right? So look at this particular equation, or you can take this equation as well. I am going to take this one. Since a is equal to d, I am going to substitute it over there. So here, taking this particular equation, in the place of d, I have substituted a. And I have opened the bracket, a and a get cancelled. I will get am is equal to 1 by n. Cross multiplying, I will get a into m into n is equal to 1, which is exactly what we want. We need to show that this value is equal to 1. So we have finally shown that the mnth term of this particular progression is equal to 1. Okay, so write down the data given in the question. Write down the information that you already know, write down the required equations and then manipulate. Look guys, as I told you and I keep telling you also, there are multiple ways of doing a particular sum. So the one way that I explained was the way that happened to me in the first place. But since there are other ways of doing this particular sum, I have written one more way in which you can manipulate this. Again, it requires quite a number of steps and some manipulations also. But if you are interested, you can have a look at it, and if it is possible, figure out another way. Otherwise, you can choose one of these and then proceed with the sum. See, I have written it completely on the board. It is like ulta pulta here, here and all. So, I have drawn an arrow. You start from here, then you go here, then you come here and here it ends. Okay, just have a look at it and see if you are able to understand. How many 3-digit numbers are divisible by 7? So this question can come in a variety of ways. How many 2-digit numbers are divisible by 3? How many 5-digit numbers are divisible by 11? So on and so forth. So different combinations, and you can form your own questions. If you already know the answer, in order to practice, you can form your own question and solve it and see whether your answer is correct or not. Okay. To do this particular sum, you need to know the first term that is divisible by 7. So what is the first 3-digit number that is divisible by 7? Before I proceed with all that, forget this question. Among the 2-digit numbers, can you tell me the numbers that are divisible by 5? I am taking a very easy one. So let us not say 2-digit numbers, numbers lesser than 100. So I will get a 5, 10, 15, 25, 30, 35. It goes on till it reaches 100, obviously. What pattern can you see here? You can see that each number, the common difference is a constant which is equal to 5. So basically they form the multiples of 5. So they have to differ, the consecutive terms have to differ by 5. Similarly, if I am taking the numbers which are divisible by 4, I will get another AP whose common difference is a 4. Similarly, in this particular question, if I am taking the 3-digit numbers which are divisible by 7, I will again get an AP whose common difference is a constant which is equal to 7. Okay, now let us start the sum. So we basically get an AP whose common difference is 7. Now, what is the first term? You know that the first 3-digit number divisible by 7, we can find it out very easily. It is 105. 105 is divisible by 7, giving us 35. Okay. Now, we have an arithmetic progression. It goes on. Okay. We need to find the number of terms which are the 3-digit numbers which are divisible by 7. It is going on and somewhere it is ending. So let us call the last term as the nth term, assuming there are n terms in this particular arithmetic progression, the last term being an. Now you can see one more thing I need to tell you is that sometimes in the question, if a variable a is given to you, you can also represent the nth term as a tn. Using t also you can represent. So I have taken an over here right now. Sometimes in your class you might be using tn. So likewise change the variable representation, that's all. So you have got nth terms, the last term an also being divisible by 7. Okay. How do you write the formula? A plus n minus 1 into d. Correct. A, I know the value. N, I have to find the value, and d also I know the value, which is a 7. Now, an is the last 3-digit number that is divisible by 7. So, can you find the last 3-digit number which is divisible by 7? Let us see how we can find it out. What is the largest 3-digit number? It is 999. $994. If you subtract this 5 from 999, we get a number that is completely divisible by 7. So 994 is the last 3-digit number that is divisible by 7. So my an value is 994. Now you have got a very simple linear equation. You just need to find the value of n. So let us figure out how many terms are there. So here you can see that I have taken 105 to this side, giving me 889, and I have solved for the value of n as 128. There are 128 numbers which are divisible by 7, which comprises of 3 digits. Okay, so can we do one more sum which goes along the same lines? The first number, as you can see, is 1001. The common difference is 11. The last 4-digit number, I have taken the highest 4-digit number, normal division, and I figured out that it is luckily divisible, or I can say an is equal to 9999. Now, in order to check if a number is divisible by 11, you know there is a very easy method. You just need to take the sum of the alternate digits, which means this plus this minus this plus this has to be a number divisible by 11. For example, 999. Let us see whether it is divisible by 11. Take the sum of the alternate digits. Now this does not have a pair, so it has only 9. 9 plus 9, 18, minus 9 will give me 9. 9 is not divisible by 11. So this number is not divisible by 11. Take any random number. 2424. Okay, or let us take 2442. This number plus this number is a 6. This number plus this number is a 6. It gives me a 0 which is divisible by 11. Now let us see whether 2442 is actually divisible by 11. 11 2s are 22. 24, 11 2s are 22 again. See, it is divisible. This is basic. I guess all of you might be knowing about this. But still I thought I will make a mention of this in case you have forgotten this. This is a concept that you study in grade 5 or grade 6. So now let us move on with our sum. Since we got the nth term as 9999, I am substituting it in the formula. An is equal to a plus n minus 1d, substituting the values of a and d over here and solving it in order to find the value of n. I am getting 819, which means there are 819 numbers of 4 digits which are divisible by 11. Okay, I hope you have got a proper understanding of this type of sum. So, if the pth term of an arithmetic progression is q and the qth term is p, show that the nth term is p plus q minus n. So, it is similar to the first sum that we did. So, now let us write down the information that we have from the question. Pth term, the formula is a plus p minus 1 into d. It is given to be q and the qth term is given to be p. we need to find the nth term, which is A plus n minus 1 into D. And we need to show that this is equal to P plus Q minus N. Okay, this is what we need to do. Okay, now let us see how we can sort it out from this particular question. Now here the RHS, one is Q and one is P, so I cannot equate both the equations, but what I can do is that because A is common, I can eliminate A by doing 1 minus 2. So let us see what we are getting. A minus A will get cancelled. P minus 1 into D minus Q minus 1 into D is equal to Q minus P. This is the RHS. Okay, let's open the bracket. P into D minus D minus Q into D plus D is equal to Q minus P. Now you can see that you can cancel D also. So you get P into D minus Q into D is equal to Q minus P. Now D is a common factor. I am going to take it out. D into P minus Q is equal to minus of P minus Q. This is Q minus P. I took a minus 1 outside. So I get a P minus Q. Now as I told you, do not cancel because that is not the right way of doing math. P minus Q is common. Let us take it outside and group the other terms inside a bracket. So from here, I have written it over here. So this term I have taken to the LHS. Now P minus Q is common. So I will get inside the bracket D plus 1 is equal to 0. Now here P is not equal to Q. So this term is 0. So D is equal to minus 1. So I am getting the common difference of this particular progression as a minus 1. But in order to find the nth term, I not only need D, I also need A. Now let us substitute the value of D is equal to minus 1 in one of these equations and see what I am getting as a value of A. So here you can see that the value of D equal to minus 1 is substituted in the first equation, which is A plus P minus 1 into D is equal to Q. So when I am substituting D is equal to minus 1, you are getting the value of A as P plus Q minus 1. Once you get the value of A as P plus Q minus 1, since you already know the value of D is equal to minus 1, you can substitute it in the formula for the nth term, which is A plus n minus 1 into D. So when I am substituting and then I am rearranging, I will get finally An is equal to P plus Q minus N, and that is what we need to prove. If the pth, qth and rth term of an AP are A, B, C, we need to show this. Now this is given as a HOTS sum or a higher order thinking skill sum in R.D. Sharma. Now let us see how we can figure this out. Now the first thing that I did when writing down the formula for the nth term, or as is given the pth, qth and rth term is, see, the pth term is given by A plus P minus 1 into D, correct? But it is given to be A. Now what is the problem over here? The first term notation and the pth term notation is the same. So there is always a chance that, not always a chance, 100% you will get confused with which A you are dealing with. So here I cannot change the question. So I am going to change the first term into X. So the first term of this arithmetic progression is X and the common difference as usual is a D. Okay, to avoid any confusion between what I am using as the first term and as the pth term. Okay, so I have written the pth term is X plus P minus 1 into D, qth term is X plus Q minus 1 into D, and X plus R minus 1 into D is equal to C. Now you can see that I cannot equate any of the statements because the RHS are all different. So what will I do? I will check for any common terms in the LHS. I can see that X is common. So let me try to subtract. Okay. Before subtracting, see what you need to prove. You need to prove A minus B into R plus B minus P into P, B minus C into P plus C minus A into Q is equal to 0. So we need to get A minus B. A minus B can be gotten by subtracting 1 minus 2. Correct. So let me do 1 minus 2. So LHS minus LHS is equal to RHS minus RHS. Correct. X minus X, it is a 0. P minus 1 into D minus q minus 1 into d is equal to a minus b. You will get pd minus d minus qd plus d is equal to a minus b, or you will get pd minus qd is equal to a minus b, or d into p minus q is equal to a minus b. Okay, this is the first relation that we are getting from this particular manipulation. Now, we can see that in the question, it is not only about a minus b into r. There are two other terms which consist of b minus c and c minus a. How can you get b minus c? We can get b minus c by subtracting 2 minus 3. Let us do that. 2 minus 3 also should give us a similar answer. So, 2 minus 3, LHS minus LHS is equal to RHS minus RHS. LHS minus LHS, x and x will get cancelled. So, b minus c. I am going to open the bracket and I will be getting, okay, when you open the bracket, you can see that d will get cancelled out just like the way it got cancelled out here. So, d into q minus r is equal to b minus c, that is our second one. Okay. Now, in order to get c minus a, I need to do 3 minus 1. So, I am going to write it out directly because it is in the same pattern as this and this. So, I will get c minus a is equal to rd minus pd, or d into r minus p is equal to c minus a. Okay. So, we have gotten a minus b, b minus c and c minus a. What do we need to prove? A minus b into r, b minus c into p plus c minus a into q is equal to a 0. Okay. In order to get a minus b into r, I have to multiply a minus b with an r obviously. So, which means I have to multiply d into p minus q also with an r. Okay. So, a minus b into r is actually equal to d into p minus q into r. Let me open the bracket. dpr minus dqr. This is a minus b into r. Okay. Similarly, b minus c into p. b minus c into p is dp into q minus r. Which will give me dpq minus dpr. Okay. Now, the last one, c minus a into q, is actually dq into r minus p, which is dqr minus dqp. Now, our task is to add a minus b into r, b minus c into p and c minus a into q. Let us see what we are getting. So, here you can see I have taken the terms dpr minus dqr, dpq minus dpr and dqr minus dqp. When I am writing it over here, you can see that plus dpr and minus dpr, minus dqr and plus dqr and this, they all get cancelled, giving us a 0. Though it was a higher order thinking skill sum, I find that it is pretty much easy. You just have to write the formula for the relevant term over here. Look at the question. Because you cannot equate anything, subtract 1 minus 2. Accordingly, b minus c will give you 2 minus 3 and c minus a is 3 minus 1. After doing that, once you get a minus c, b minus b, b minus c and c minus a, multiply with an r here, p here and q here, and then add it up. Okay. So, try to do it on your own once and only then look at the solution if you are not able to figure it out. The main thing in this kind of sums is the grouping and the sign of the sums. So, maximum terms cancelling out will actually help us in solving any kind of proving sums. The sums that we did today were slightly, above average sums, and see, you can never tell what comes for the exam, but this is a maximum level, they can give you sums from arithmetic progression. They will not give you, exceptionally tough sums for your board examinations. Okay. So, I want you to keep practicing so that you can get used to these kind of sums, especially, the sums where numbers are not involved, variables are involved and, you have to prove something. So, those kind of sums, unless you keep practicing, you will never learn how to do it, within the given time. And the second thing is that Please write legibly. It is very important in arithmetic progression because the terms are very long. Do not make it too cramped so that it becomes difficult not only for the examiner, even for yourself to read when you are writing the examination. So keep these things in mind and keep practicing.